Welcome back, everyone, to the deep dive. Today, we're diving into a pattern that pops up all over in software, the iterator pattern.
Yeah, it's one of those fundamental building blocks you find everywhere, especially when you're working with collections of things.
You know, like when you've got a bunch of data to work with and you need to go through it one by one. Like imagine a list of users on a social media platform or all the items in an online store.
Or even simpler, think of all the tasks on your to-do list.
Right. And the thing is, these collections, they can be stored in all sorts of ways behind the scenes, right?
Absolutely. Some are simple lists, others are more like dynamic structures that can change size on the fly.
So the question is, if you want to go through each item, do you really want your code to have to know exactly how that data is organized?
Well,
It seems kind of messy, doesn't it?
it would be a nightmare, honestly. Imagine needing a different set of tools just to read each type of container. You'd never get anything done.
Exactly. And that's where the iterator pattern swoops in to save the day.
It's all about giving you a consistent way to walk through any collection, no matter how it's structured under the hood.
So like, I can just say, give me the next thing, and it hands it over without me needing to know if it's pulling it out of a box, a bag, or a magic hat.
You got it. It's like having a universal remote control for your data.
Okay, I like that analogy. So less fiddling around, more actually getting stuff done. Why don't we break down how this magic works?
Sure. So one of the big ideas here is this concept of encapsulation. It's like
Right.
you don't want your code to be poking around in the guts of the collection, messing things up accidentally.
Yeah, like you don't want someone reaching into the engine of a car when all they need to do is steer.
Right. The iterator pattern helps keep those internal details nice and hidden, making your code safer and easier to change later on.
Makes sense. So you're saying we should treat the collection kind of like a black box. You put stuff in, you get stuff out, but you don't worry about the how.
Exactly. And the other big win here is that you can have different ways of going through the same collection. Like maybe sometimes you want to look at every single item, but sometimes you only care about specific ones.
Oh, like if you're searching for something particular, you don't need to go through the whole haystack.
Exactly. The iterator pattern lets you define different traversal strategies, like different paths through the data, without cluttering up the collection itself with a million different methods.
So it's like having different sets of directions for the same destination. You choose the one that suits your needs.
That's a great way to put it. So instead of the collection being responsible for both holding the data A and D, figuring out how to walk through it, we pull that walking through logic out into a separate object, the iterator.
It's like having a tour guide for your data, someone who knows the best route.
Exactly. And that tour guide, the iterator, typically has a few essential actions it can perform.
Okay, like what does our tour guide need to be able to do?
Well, first, it needs to be able to get you to the starting point. Let's call this the first operation, kind of like take me to the beginning of the exhibit.
Makes sense. Got to start somewhere.
Right. Then you need a way to move to the next item, which we usually call next. It's like saying, okay, what's next on the tour?
Okay, so first, start. Next, to move along. What else?
You also need a way to know when you've reached the end, when you've seen everything. So there's usually an is-done method for that.
Like are we there yet? Check for your data tour.
Exactly. And finally, you need to be able to actually get the item at your current position, which is often done with a current item operation.
So you're at a particular point in the collection and you want to see what's there. Makes sense.
Precisely. So those four actions, first, next, is done, and current item, give you a basic framework for navigating any collection.
Okay, I'm seeing the structure here. But why go through all this trouble to create a separate iterator object? What's the real payoff in practice?
Well, this is where the magic of flexibility and decoupling really shines. Because you've separated out the traversal logic, you can have multiple different ways to go through the same data without changing the collection itself.
Okay, give me an example. How would that actually work?
Let's say you have a list of customer orders for an online store. One iterator might just go through them in the order they were placed.
Simple enough.
Right. But what if you wanted to say, only process orders that haven't been shipped yet?
You'd need a different path through the data.
Exactly. You could create let's call it a pending order iterator, which would only give you those unshipped orders. And you wouldn't have to touch the original order list at all.
So it's like having different filters for the same data set, different lenses to view it through.
Precisely. And this leads to what we call decoupling, where the code that's using the iterator doesn't need to know anything about how the data is actually stored.
So it's like the client code doesn't care if it's dealing with a box, a bag, or that magic hat we talked about.
Exactly. All it cares about is that it can get the next item. This makes your code way more adaptable because you can change the underlying storage without breaking everything.
It's like future-proofing your code.
Right. And here's another cool thing. Because each iterator keeps track of its own position, you can have multiple iterators working on the same collection at the same time.
Whoa, wait, so it's like multiple tour guides going through the same museum, each leading their own group?
Precisely. They each have their own separate bookmark, so to speak, so they don't step on each other's toes.
Yeah.
This can be super useful for things like comparing two sets of data without having to load everything into memory at once.
Okay, that's pretty neat. So we've got the collection, the iterator, different types of iterators. Can we break down the formal roles in this pattern just to make sure we're all on the same page?
Of course. So think of it like this. We have interfaces, which define what each component should do, and then concrete classes, which actually implement that behavior.
Okay, the blueprint versus the actual building.
Perfect analogy. So first, we have the iterator interface. This lays out the basic operations we talked about. It has next, next, and sometimes that optional remove method.
So it's like a contract that all iterators, regardless of the collection they're working with, need to follow.
Right. Then we have concrete iterator classes. These are the guys who actually do the heavy lifting.
The ones who know how to navigate the specific type of collection.
Exactly. Each concrete iterator is tied to a specific collection type and knows how to get the next item, check if there are more items, and all that good stuff.
So like you'd have a list iterator for working with lists, a set iterator for working with sets, and so on.
Precisely. Now, on the collection side, we have the aggregate interface. This interface has one main job: to create iterators.
So it's like a factory for iterators specific to that type of collection.
You got it. It usually has a method called createIterator, which, well, creates and returns an iterator that's designed to work with that specific collection.
Okay, so the collection knows how to make the right kind of tour guide for itself.
Exactly. And finally, we have concrete aggregate classes. These are the actual collections themselves, like the specific lists, sets, maps, and so on.
The actual data containers?
Yep. They implement that aggregate interface, and their createIterator method is responsible for making the right kind of iterator for their data.
So it's a nice, clean system where each part has its own specific responsibility.
That's the beauty of good design patterns. Now, how about we bring this all together with a real-world scenario? Let's say you're building a music streaming app,
Ooh, I like where this is going.
and you've got two different sources of music data. One's a database, and the other is, let's say, a simple file system.
So you're pulling songs from two different places.
Right. Now, you want to display a list of all available songs no matter where they come from. Without the iterator pattern, you'd need to write code that handles both the database results and the file system structure separately.
Yeah, that sounds like a recipe for spaghetti code.
It would get messy fast. But with the iterator pattern, both the database and the file system can implement a common interface. Let's call it music source.
And that interface would have the createIterator method.
You got it. So the database would return a database iterator, which knows how to go through database results, and the file system would return a file system iterator, which knows how to walk through directories and files.
And both of those iterators would adhere to the common iterator interface.
Exactly. So now your music app doesn't need to care where the songs are coming from. It just asks for an iterator from each music source and uses the has next and next methods to get the songs.
So it's a clean, consistent way to work with data from different sources, all thanks to our trusty iterators.
Now you're getting it. And let's touch on a few important points about how iterators are implemented. We've mainly been talking about what we call external iterators.
External, what's that mean?
It means that the client code, like our music app, is the one controlling the iteration. It's explicitly calling next to get each item.
Okay, so the client is driving the tour bus, so to speak.
Exactly. There's also something called internal iterators, where the iterator itself takes care of going through all the items and applying some operation to each one. It's kind of like saying, hey, iterator, apply this discount to every item in the list.
Ah, so the client is delegating the whole tour to the guide.
You got it. Now, internal iterators can be handy for simple operations, but external iterators give you a lot more flexibility and control, which is often what you need in complex scenarios. And for interview prep, it's good to be able to talk about both types.
Right, showing that you understand the nuances and trade-offs.
Exactly. And speaking of interviews, it's also important to know that many languages, like Java, have built-in support for the iterator pattern.
Oh yeah, I've definitely seen iterators in Java code. How does that work exactly?
Well, Java has an interface called java.util.iterator, which defines those familiar has next, next, and remove methods. And it has another interface called java.util.iterable, which basically says, hey, I can provide an iterator.
So if a class implements iterable, it's promising that it can give you an iterator to work with.
Exactly. And most of the standard Java collections, like ArrayList and HashSet, already implement iterable. So in our music app example, if the database results were stored in an ArrayList, we could just use the ArrayList built-in iterator and save ourselves some work.
Nice. Less code to write and less chance of making mistakes.
Absolutely. But for something like our file system example, we probably need to create a custom iterator that knows how to traverse the file system structure. Even when you're using built-in language features, the core idea of separating traversal logic still applies.
So the concept is universal, even if the specific implementation might vary.
Exactly. Now, remember that music source interface we talked about for our database and file system?
The one with the create iterator.
Yep.
With that one.
By having both our database and file system implement that interface, our music app can treat them both the same way. It doesn't need to know the specifics of each data source.
So it's even more decoupled and flexible.
Precisely. This is a big win for maintainability and testability, which are always good points to bring up in interviews.
Makes the code easier to understand, change, and test.
Now, for those of you prepping for Java interviews, there's this cool thing called the enhanced for loop, or for each loop. It makes looping through collections super clean and easy.
Oh yeah, I love those. They're so much more concise than writing out a full for loop with an index.
But what's interesting is that under the hood, the enhanced for loop is actually using an iterator. It's just doing it implicitly, so you don't have to write all that has next code yourself.
So it's like syntactic sugar, making the code look nicer without changing the underlying mechanism.
Exactly. However, it's worth noting that standard Java arrays don't directly implement the iterable interface. So if you need to use an enhanced for loop with an array, you'd still need to wrap it in something that provides an iterator.
Interesting. So even with these convenient language features, understanding the iterator pattern is still important.
It helps you see the bigger picture and appreciate the design decisions behind those features.
Okay, so we've gone through a lot. Can we just recap the main benefits of using the iterator pattern, especially in light of our music app example?
Of course. First, it simplifies the interface of the collections themselves. Our music source interface only needs that one creator method rather than having a bunch of methods for different ways of accessing the data.
So the collection can focus on managing the data, and the iterator handles the traversal.
Right. Second, it allows for different traversal strategies. We can have one iterator that goes through all songs, another that filters for a specific genre, another that sorts by artist, and so on, all without changing the music source classes.
Different ways to slice and dice the data.
Exactly. Third, it allows for what we call polymorphic iteration. The music app can work with any object that implements the music source interface, regardless of how it's actually storing the music data. It just gets an iterator and works with that.
So it's adaptable and doesn't rely on specific implementations.
Right. Fourth, it provides encapsulation. The internal workings of the database and the file system are completely hidden from the music app. It just uses the iterator, so it doesn't accidentally mess with the data storage.
Keeping things safe and organized.
And finally, it follows the single responsibility principle. The music source classes are responsible for managing the music data, and the iterators are responsible for traversal. Nice, clean separation of concerns.
It's all about making the code easier to understand, maintain, and extend. So big picture, why should someone prepping for a senior software engineer interview really care about the iterator pattern?
Because it demonstrates that you understand how to build flexible and well-structured systems. It shows that you can design code that's not tightly coupled to specific implementations and that can adapt to changing requirements. These are valuable skills for any senior developer.
So it's not just about memorizing a pattern, it's about understanding the principles behind it and how they contribute to good software design.
Precisely. And for those Java interviews, remember that little detail about the remove method in the iterator interface?
Yeah, it's optional, right?
Exactly.
Mm-hmm.
If it doesn't make sense for a particular collection, the iterator can just throw an exception if someone tries to use it. It's a small detail, but it shows that you're thinking about the edge cases and potential pitfalls.
The devil's in the details.
Sometimes.
Well, this deep dive into the iterator pattern has been really enlightening. It's amazing how such a simple concept can have such a big impact on how we design and write code.
It's one of those patterns that once you understand it, you start seeing it everywhere.
So for those of you listening, think about how you might apply the iterator pattern in your own projects, or look for examples of it in the libraries and frameworks you use. It's a great way to solidify your understanding.
And as you prepare for your interviews, consider how the iterator pattern relates to other design principles. How does it promote loose coupling? How does it help you write code that's open for extension but closed for modification? Being able to make those connections will really impress your interviewers.
Excellent advice. Thanks for joining us on this deep dive, everyone. We'll see you next time.